in week 5 with the integrated terminal, and you can also verify whether NumPy is installed on your computer by simply, first of all, if you're using an IDE like Microsoft Visual Studio, it can automatically detect whether NumPy is installed on your computer when you actually NumPy demo.py, when you import the NumPy package, import NumPy as NP. So it automatically detects that NumPy is installed. If you are using any simple editor, what you can do is in the terminal, you can open Python 3 terminal and you can check import NumPy as NP by running this command. And if it does not give you any error, it means that NumPy is already installed on your computer. Okay. So I'm killing this interpreter and going back here to write some code on it. So let's say we have a data 1D equals say 1, 2, 3 and 4, and then I can create array 1 equals, you can see NP. Now because I have given it an alias already, NP, so I can simply use NP dot array, and in path I can pass data1 D and then print array 1. So when I run this code, Python 3, what is the name, numpy-demo.py, and it creates a one-dimensional array 1, 2, 3, 4, and here you can clearly distinguish by looking at it that if it would be a list, it would simply have a comma separated elements in a list like this. I can also create a two-dimensional array by, let's say, data 2D, and I can have first element as data 1D. Data 1D is already a list, right? And I can also have another list, let's say 5, 6, 7 and 8. And now I can, instead of creating one-dimensional array, I'm now creating two-dimensional array and giving it a name 2D, and here array 2D. Okay, so let's run this code again, and you can see the two-dimensional array is created 1, 2, 3, 4, 5, 6, 7, 8. And if you would be only printing, let's say print list and array, data 2D. If I were to print this, and let's say this is array NP array, so you can see a clear difference between these two things. Maybe I can \n, similarly here also \n. So NP array is visible to you really in the form of a two-dimensional array. It's the first row and the second row is clearly visible. You can, in contrast, list contains the nested list, but they are all arranged along the same row. Okay, so this is why one of the reason, because you have like a multi-dimensional, not only two-dimensional. You can have like 10 rows, 10 columns, and you would be able to visualize all that data in an intuitive way, rather than having all the nested elements printed along the same row. Okay, so this was one of the thing. Let's try running some operations. Let's say we have a operations, And in operations, let's say array 1 equals 2 3, and we can also have array 2 same 1 2 3, and what we can do is print np dot, sorry, first of all I have to create this as an np dot array, and again I have to pass this list into a set of braces np dot array. And if I do this, yeah, so we are passing a list inside the np.array function. So it creates two array 1 plus array 1 and array 2, and now I'm doing array 1 plus array 2 here. Just for the time being, I'm just commenting these two things out and run this, and you see you'll get the array 1, 1 plus 1, 2 plus 2, and 3 plus 3, 2, 4, and 6. I can also consider like multiplying this and see what we get. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So we can perform these kind of operations by using simple arithmetic operations, unlike in list, which simply concatenates if we were using a plus operator. Okay, so let's go back to the slides. Yep.
So like the NumPy function like didn't work, even though like it said in the terminal that it was like downloaded successfully.
NumPy function is not working?
Yeah.
Okay, I will check once the slides are completed. Okay. Okay, so let's go back to the slides. Okay, so these are some operations that you can perform, addition operation, subtraction, multiplication, and dot array. You can also perform like a matrix multiply with the help of a dot method, and p dot and array 1 and array 2 you can pass and see or it gives you the output, and np dot sqrt is square root of each element in array 1 if you're passing the array 1, and then we can also find the minimum element and the maximum element. So these are very useful methods which you can perform. For example, I gave you an example of the grade sheet that I was developing. So along the same row, for example, a particular student, I can determine where did you score maximum with the help of simple running maximum function. Similarly, we can find out the minimum and so on. Okay. So we can also generate identity matrix. So if you have already studied the matrix chapter in your elementary math, you know that we can generate the identity. We can have an identity matrix with all ones diagonally arranged, or we can generate this kind of matrix with the help of I method. There is an I method which we specify the length of the identity matrix, like how many rows and how many columns would be there. And we can also use an identity method to generate the same identity matrix. Okay, and here you can also generate the matrix containing random elements. So random elements between 0 to 10 and how many rows and columns you want. So let's see this. So for example, here I can do print np dot, let's say, identity, and identity matrix of 4. Let's run this, and you see it generate an identity matrix of 4 rows and 4 columns. I can also try what we were talking about, random. So random np dot random dot random integer, and what we need to specify in this is we need to generate a matrix of random integers between the range 0 to 15, for example, and how many rows and columns we want. Let's say 4, 4. Okay, let's run this, and you can see it generates a 4 rows 4 columns matrix with all the elements randomly inserted between the value 0 and 15. These are very useful things when you would be dealing with data related objects, data science projects, and these are so that's why NumPy is very important to learn and practice with. Okay, so let's go back here. Yep. And there is another thing in the slicing. One-dimensional arrays are simple on the surface. They act as a simple to Python list. So for example, here if I have this code np.arange, arange generates a sequence of numbers, integer numbers. Okay, so when I specify 10, it will generate a number from 0 to 9. 10 is excluded only in the integer sequences. If it would be floating point sequence, fractional sequence, then the AND parameter is always included. Well, when we write this code print array, it simply prints this, and print array 5, it would print, what do you think it would print? So array contains an array containing these numbers. So when I write execute print array 5, what do you think would it print?
0 to 4.
Why? This is the array, and we are specifically accessing the element at index number 5. So it would just simply print 5. Okay, here slicing print array 5 colon 8, it would print the elements from 5 to 8. 8 is exclusive. Okay, so 5, 6, 7.
So it wouldn't print 4.
Hmm?
Because like I thought, since like 4 would be like the diff index.
4 would be what?
The diff index, because you include 0.
Which line? Here?
Oh, no, the one above.
Here?
Yeah.
So if I would write 0, 4, right? So 4 would print, so because 0 is placed at the 0th index. So 0, 1, 2, 3, 4. 4 will be printed. Okay, because we are dealing with the 0th index elements. So here, when this line, the array 5 colon 8, we are actually updating the values of an array between 5 colon 8. 8 is exclusive. So it will be updated with value zeros. And then when we print array, it will print this thing. So this is the reason why we say that the data is not copied. The value is propagated or broadcasted to entire selection here. So when I say 5 colon 8 and update this value, so it updates this value with the new value that we specify. So any modifications that we are making here will be reflected in the main source array. Unlike list, where it creates a copy, whenever we use a slice function, it actually creates from the main list, and when I'm specifying this slice, it actually extracts those elements and create a new list. Here it do everything within the same array. Okay, so when I'm specifying array 5 colon 8 equals 0, it is not creating a new list, it is not creating a new array, it is just rather updating the values in the same array. Okay, so in this regard, it is also memory efficient because it does not create a new array and add those new elements in it. It just go into the same source array and make the changes in the same way. Okay, so let's move on. So in a two-dimensional array, the elements at each index are no longer scalars, but rather one-dimensional array. So once we specify this, here print array 1, so how we can access the first row. So this is the zeroth row, the zeroth row, first row, and the second row. So in order to access this row, we can just simply write print array 1. What if you need to access individual element, and we have to specify the row and column using either of the two following ways. So, for example, if you have to access the second element in this row, which is the second row, or the first row if you are talking about the zeroth indexing. If it is 0th row, this is first row. If I have to access the last element of the first row, what do you think we should be writing? Array 1 would be accessing this row, right? Array 1 would be accessing this row, and simply accessing any element within this one, you could simply follow the same procedure of list. You specify the index of that element. So here print array 1, access this first row, and accessing the second element you just specify 2. Okay, there is one way. The second way is print array 1, comma 2. It also means the same thing. So this is exactly the similar way that you have used in list, accessing elements in the list, and this is another approach where you just write the comma separated dimensions. Okay, so let's see this here. Okay. So for example, if I have, let me do this here, Python 3, and let's say I have array 2D array equals first of all I need to import NumPy as np, and array equals np.array, opening and closing braces, first dimension 1, 2, or let's say 9, 8, 7. The second row is 1, 4, 5, and the third row is, let's say, 6, 4, 5. Okay, so what I'm missing here is this. Okay, I think there is a, okay, yeah. It takes only a single list, and I have like nested list within a list. So array function takes only one list, and if you have to specify multiple list, it has to be enclosed in a single list. Okay, now if I print array, this array is created. Now if I have to access print, let's say print, or simply write array, the first row, so first row and second column, which is 5. So I write first row and this one, and it gives me that particular element. I can also write it like this, and it gives me the same thing.